Hello and welcome to Fixing's Cast into Concrete, where we'll be looking at best practice when casting holding down bolts into concrete bases. We'll be joined by subject matter expert Bhavika Ramrakani here at the A14 Laboratories, where we'll be looking at a number of experiments to understand the stresses and strains concrete fixings can endure. But first of all, let's go to Michelle, our reporter on site. Hi Michelle, how's everything going?
Thanks, Russell. As you mentioned, I'm here on the A14 and I'm joined by two project engineers, Esther and John, who are here to explain their experience with cast-in fixings. So to start with, what are you doing here?
Well, a large part of my job here has involved the construction of these gantry bases.
Someone mentioned there were over 100.
Yeah, that's true. Thankfully, not all 100 are on this section though.
And they carry the gantries that support the signs that span right across the motorway, is that right?
Yeah, that's correct. And what really surprised me is just how big they are when you get close up. This one you can see has got 28 bolts on it. That seems really excessive, but when you consider the weight of the gantries, which can be many tons, and you also consider wind loading, potential impact loading and bending strain, it's not that excessive.
So John, do the bolts ever fail?
Of course the bolts can fail. That would be disastrous. There are four main things we need to consider. We need to consider ordering the right materials to the right specification. We need to consider that the gantry base and the bolt cluster is in the correct position by setting it out correctly and using templates. We need to ensure there's enough waggle in the bolts by loosening them during the concrete pour. And we need to ensure that we follow the right bolt tightening and grouting procedure.
You mentioned waggle there. We're actually going to look into that later, but basically what is it?
So when we cast the bolts into the concrete, you only get one chance to get the bolt cluster in the right place. So all the bolts are set in cones, which ensures there is enough tolerance on the bolts for movement when we land the gantry.
Okay, thank you. We're now going to pass back to Russell to catch up.
So, I'm now joined by Bhavika, who's going to talk us through a couple of experiments and explain in further detail the process that the project engineer is referring to. Over to you, Bhavika.
Oh, hi. So initially, these bars are fixed with the bolt group in cones ready for the concreting.
And I would expect that by casting the bolts in concrete, it makes for a really robust anchorage.
Well, it does. I'll show you if you want to come around here. So we have got here a movement in there. For example, in this case, we have left sort of 30 mil of movement in there. So the bolts are actually well fixed at the anchorage. And the reason we are leaving this 30 mil sort of movement is so that the base plate of the gantry stanchion will go on without forcing the bolt over.
Okay. And if we go back to our model over here, I understand that there would normally be rebar running through that, but for the purpose of the video, they've taken that away.
Yeah, it's just to give, this is a model for demonstration. Yeah.
So as it stands, though, without the rebar there, that's all correct and would be ready to have the concrete poured into it?
Yeah, we would have, I mean, all the specifications will be checked, all the positions of these bolts will be checked, their fixity will be checked. So yeah, everything is perfect and it's ready to go.
Okay. In terms of the fixity, what's this plate on the top for?
That's the template, and I'll show you. So if you want to come around here, that's got the markings at it, so that it sort of sets accurately.
And just how accurate is that template that you've shown me?
The template is accurate. So if you have got a gantry base on site, it's probably 5 mil. So 3 mil would be better.
Right.
The template is actually fixed to the shuttering and not to the rebars, so that this all becomes very rigid. We need to make also sure that the bolt group is the right way around and they need to be at the right level so that everything can work properly.
And why are the bolts covered with this Denso tape like this?
You can either cover it with the Denso tape or you can use the caps. The reason you are doing it is because when the concrete is placed, it's really important that the tabs are kept sort of neat and clean, so that when the nuts go on it, we need to make sure that the concrete does not go into the cones, otherwise the waggle is lost.
And why don't the bolts set rigid in the concrete?
You wouldn't want them to settle rigidly. After the initial set-in, which is sort of 2 hours, we just crack the bolts a bit to make sure the bond is broken, and then again we'll come back to it after a couple of hours and check it, that if there is a movement in there still.
Okay, and what happens if somebody forgets to do that?
we have a problem then, and we take it very seriously.
Okay, well that's something to look at later on. Let's go back to Michelle over on the site on the A14. Hi Michelle, how's it going?
Some interesting experiments taking place at the lab. We're now here at an almost completed gantry. So is it possible to over-tighten a bolt?
You certainly can. Tightening often gets overlooked. It seems unlikely with big bolts like these ones behind us, but with a long handle on a socket wrench, you can easily shear a bolt clean off.
What should you use?
You should always use a torque wrench that's set to the correct torque. It should feel just right, and if there's something wrong, you need to stop and find out what it is. So plan your tightening, the controls and the tools. With large arrays of bolts, the sequence also becomes really important.
That's a lot to remember. Specification, template, waggle and tightening.
It is, so I have engineers checking at every stage to tell you what is needed. It's all written down in the method statement and the ITP, which is the inspection and test plan. That's where you find the detail.
Great, thank you. We'll now head back to the lab who will look into things in even more detail.
Thanks Michelle. So now we're going to look at the waggle.
Yes, waggle matters because concrete will never be as accurate as fabricated steel. You need some sort of movement or waggle.
And presumably you don't want to bend the bolt over.
Absolutely not. It will just snap. Despite their strengths, bolts are brittle, and even if you do get it to fit it to the base plate, when load comes on and stresses increase, the fatigue will set in.
So a failure could occur in just a few years.
Oh, it might be a matter of few weeks.
But doesn't the fact that it has waggle mean that it's weaker?
Well, no. First, head of bolt is fully held by the anchorage, as we saw in the first samples, before concrete was poured in. And secondly, it will be all grouted up in the end.
Okay, so what else should a project engineer who's on site be thinking about?
How well fixing could be in wrong location, not properly templated or damaged. Then after the concreting has been done, tightening needs to be done right. And it has to be in the right sequence. With the grouting, not forgetting the lock nuts if they are specified.
And you've seen all these things?
Over the years, yes. I've seen bolt groups where a mistake has been made by setting out the whole group 90 degrees out, and also where the level is wrong and not enough thread has been left sticking up to get the nuts on.
And how much thread is that?
It's surprising how much. We're going to see the experiments a bit later on. The bolts that we are using are M20 bolts, and there is around 90 mil sticking up above the concrete, enough for a grout bed, a base plate, which could be 60 mil thick or more, a nut, a lock nut, and a spread thread showing. For a big bolt, you might need 150 mil or more.
And when things go wrong, what can be done?
Well, once the bolts are cast in, there's not much you can really do, except either break out the concrete and start all the process again, or do a post-drill fixing.
That sounds like a lot of work.
Yes, and it would cause lots of delays and plenty of embarrassment. Also, you're trying to get a post-fix bolt into a dense rebar. That won't be an easy job. I think that's where people sometimes try to cover up their mistakes. But as the project engineer said, that can lead to a failure later on. It could be a matter of days or could be years.
That's a major worry.
Well, yes. Sometimes structures don't see their peak load for several years. Perhaps not until a big storm whips up, and then the question of fatigue, which develops over a long period of time.
So could the project engineer be worried for years to come?
No, I don't think so. He was doing a diligent job and taking pride in doing it right first time.
Can we illustrate some of these issues?
Of course, we have set up a 4-bolt group, and we're going to see what happens if you try to bend the bolts into the base plate. Now, what the technicians haven't done here was to loosen the bolts as the concrete sets in.
So there's no waggle?
Yeah, that's it, back to waggle.
Okay, so we're going to go to the other side of the laboratory and see what the technicians are doing.
So what we've got here is an experiment to show the wrong way to fix. So Len, we've got one bolt that hasn't got its waggle, and we've got another one that's fully concreted in. So I'm going to put this template on. What do you reckon?
Well, the bolts clearly haven't set in the correct position here.
So if we take that off, pop a couple of nuts on and bend these over and see what happens, yeah? Right, let's see where we got with that. Look at that. Sorted. Let's get some washers on, mate, and then torque this up, yeah? So I'm going to tighten up to 100 Newton meters.
I would like to say the bent bolts will pull straight off. At least that would be fail-safe. And in reality, what I expect will be that we'll get the design tension into the bolts, but they'll be permanently damaged. And then, if they're out on site, like on a gantry base, they'll fail perhaps after a year or two. Bolts are very high strength, but can be extremely brittle.
Well, that was quite dramatic, but tell me, if the bolts took all the initial torque, surely that must mean they're okay, despite the use of the sledgehammer?
Well, no. The first thing we saw was that one of the bent over bolts failed, so the sledgehammer weakened it. Secondly, by applying the design torque, we sheared off the bolt. Thirdly, we had a buried defect, something wrong you can't see. In many ways, that's worse. In years to come, failure will occur.
Any final thoughts?
Of course, just don't bend the bolts over. There are steps to follow to make sure the specified cast-in bolts, nuts and lock nuts are used. Then there's the grouting and the tightening procedure. Overall, it's about teamwork, everything coming together. Designers and engineers know what needs to be done, and the care needs to be taken. If you've got a problem, always call for advice.
Exactly. Okay, let's go back to the team on the A14 and Michelle for their final message.
Yeah, thanks, Russell. We've been chatting about your tests in the lab, and Esther wanted to share one last message.
Ultimately, no matter how long you've been working in engineering or construction, if there is a problem, it's better to stop the job if you have to, and please call for advice if you need it. That's what we're all here for.
Exactly. Back to you, Russell.
Thanks very much, Michelle, and thank you to everyone for your contribution to Fixings Cast into Concrete.